Welcome back, everyone. We're going to talk about some divisibility tests for our first three prime numbers, 2, 3, and 5. So first, let's list the first several multiples of the number 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. And we could keep going, but I'm sure that you noticed that the ones digit is either 0, 2, 4, 6, or 8. And that's always true if the number is a multiple of 2, or if 2 is a factor of that number. And a similar thing happens when we list multiples of 5. Well, if we start with the first positive multiple, that would be 5, and then 10, 15, 20, 25, 30, 35, 40, 45, 50, etc. Again, we notice that the ones digit is either 0 or 5. So for 2 of the first 3 prime numbers, we can tell just by looking at the ones digit whether or not 2 is a factor of a number, whether or not 5 is a factor of the number. For 3, there is a divisibility test, but it's a little bit more complicated. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. After that, 33, 36, 39, 42, 45, 48, 51, 54, 57, and 60. So we see that there are some patterns that repeat every 10 multiples. If we kept going, 63, 66, 69, 72, 75, 78, 81, 84, 87, and 90. But if you look at these numbers, notice that these numbers have a 1 in the ones digit. These ones have a 2. These 3 have a 3. Here's a 4. Here's 5s. Here's 6s. Here's 7s. Here's 8s. Here's 9s. and here's zeros in the ones digit. So we can't just look at the ones digits when we're trying to decide if a number is a multiple of 3. In other words, if we're trying to decide if 3 is a factor of that number. I'm going to do something slightly different now. I'm going to start at 150 and then 153, 156, etc. And we're going to add the digits of the number. So 150 is 50 times 3, so it's a multiple of 3. And so then 153 would be 51 times 3, and 156 would be 52 times 3, etc. And I skipped counting it all the way up to 189. When I start with 150, the digits are 1, 5, and 0. If we add those, we get 6. 1, 5, and 3, if we add those, we get 9. 1, 5, and 6, if we add those, we get 12, which is more than 9. But notice that if we add 1 and 2, we get 3. So let's keep experimenting a little bit here. If we add 1 plus 5 plus 9, that's 15. Oh, and then 1 plus 5 would be 6. If we add 1 plus 6 plus 2, well, 1 plus 6 is 7. 7 plus 2 is 9. If we add 1, 6, and 5, let's see, 7 plus 5 would be 12. Oh, and if we add 1 and 2, we get 3. One plus 6 plus 8 is 15. One plus 5 is 6. 1 plus 7 plus 2, whoops, plus 1, sorry, is 9. 1 plus 7 plus 4 is 12. If we add those digits, we get 3. 1 plus 7 plus 7 is 15. 1 plus 5 is 6. So look at this. We're getting a 9, a 12, a 15, then a 9, a 12, and a 15, then a 9, a 12, and a 15. If I bring this 9 over here, and this 9 over here, and this 9, whoops, over here, and if I bring this 6 over here, look at this pattern, 6, 9, 3, 6, 9, 3, 6, 9, 3, 6. Huh, let's see if it keeps going. 1 plus 8 plus 0, that's a 9. So 369, 369. 1 plus 8 plus 3 is 12. And 1 plus 2 is 3. 1 plus 8 plus 6 is 15. And 1 plus 5 is 6. 1 plus 8 plus 9 is 18. We haven't seen that in this list yet. That's new. All of these numbers, right, seem to be, well, there was a 6 there, but then we had a 9, 12, 15, a 9, 12, 15, 9, 12, 15, 9, 12, 15. Oh, and then this one's an 18. So that's something a little different. But notice that 1 plus 8 is 9. And the pattern here, 693, or if we start at 3, 369, 369, 369, 369. Let's try a bigger number. 1,927 times 3 happens to be 5,781. Let's add those numbers. 5 plus 7 would be 12. If we added 8, that would be 20. And 1 more is 21. So 2 plus 1 is 3. 5 plus 7 plus 8 plus 4. Well, that's going to be 24. But 2 plus 4 is 6. I wasn't sure if we're going to need to continue adding to get a number that's smaller than 10. 5 plus 7 plus 8 plus 7 is 27. And 2 plus 7 is 9. 369 again. 5 plus 7, that's 12, plus 9, plus 0. 12 plus 9 is 21 again. But 21, 2 plus 1 is 3. 5 plus 7 plus 9 plus 0 is 24. 2 plus 4 is 6. 5 plus 7 plus 9 plus 6 is 30. Did I add those right? 12. Oh, nope, 27. I didn't add them correctly. 2 plus 7 is 9. 369 again. Okay, I know where I made my mistake. It's right there. I didn't write down the 3. No wonder I was confused. All right, the next one. 5 plus 7 plus 9 plus 9. That one is 30. Three plus 0 is 3. 5 plus 8 plus 0 plus 2. Well, 8 plus 2 would be 10, plus 5 is 15. 1 plus 5 is 6. 5 plus 8 plus 0 plus 5, that's 18. 1 plus 8 is 9. 3, 6, 9. 5 plus 8 plus 0 plus 8 is 21. 2 plus 1 is 3 again. Five plus 8 plus 1 is 15. 1 plus 5 is 6. 5 plus 8 plus 1 plus 4 is 18. 1 plus 8 is 9. We've got 3 more on this page here. 5 plus 8 plus 1 plus 7 is 21. 2 plus 1 is 3. 5 plus 8 plus 2 plus 0 is 15. 1 plus 5 is 6. 5 plus 8 plus 2 plus 3 is 18. And 1 plus 8 is 9. When you add up the digits of a number, and then if that number is more than 9 and you add up those digits, and you keep going until you have a number that's less than 10, that final result is called the digital root of the number. But in this case, all of our digital roots are 3, 6, or 9. For the really large numbers, for the sort of medium-sized numbers in the 100s, what about the smaller numbers? Well, 1 plus 2 is 3. 1 plus 5 is 6. 1 plus 8 is 9. 3, 6, 9. 3 plus 0 would be 3. 3 plus 3 is 6. 3 plus 6 is 9. 3 plus 9 is 12. But 1 plus 2 is 3. So there are a couple of patterns. One pattern is that if your number is a multiple of 3, the digital root will be 3, 6, or 9. Or if you just add up the digits and then you have a number that is relatively small, all of these numbers, 21, 24, 27, 30, 15, 18, all of those numbers themselves are multiples of 3. So the divisibility test to decide if a number is divisible by 2, to decide if 2 is a factor of the number you're starting with, you only have to look at the ones digit, and it just has to be a 0, 2, 4, 6, or 8. 5 is going to be a factor of your number if the ones digit is 0 or 5. And 3 is a factor of your number if the sum of its digits is itself divisible by 3. And we can add on to that if and only if its digital root is 3, 6, or 9. So here's a big number, 2,785. Is it divisible by 2? In other words, is 2 a factor of 2,785? Or we could say, is 2,785 a multiple of 2? And the answer is no, because its ones digit is 5, which is not a 0, a 2, a 4, a 6, or an 8. That same number, 2,785, is it divisible by 5? Well, the answer is yes. Its ones digit is 5, which is a 0 or a 5. It's a 5. What about being divisible by 3? Well, if we add the digits, 2 plus 7 plus 8 plus 5, 2 plus 7 is 9. 9 plus 8 is 17. 17 plus 5 is 22. So one way to answer this question is to say, no, the sum of its digits is 22, and 22 is not a multiple of 3, or it's not divisible by 3. A slightly different way of answering the same question would be to add the 2, the 7, the 8, and the 5 to get 22, but then to add the 2 and the 2 to get a 4, and to say, no, its digital root is 4, which is not 3, 6, or 9. The fact that there are relatively simple divisibility tests for the first 3 prime numbers is something that we're going to take advantage of in the next video. Thank you for watching, listening, and taking notes, and we'll see you on the next video.